The broadcast is now starting. All attendees are in listen-only mode.
So, guys, um, we are going to record this. So, anything, all the questions you have, anything you think of, you can send us um, through the Q&A window, or you can always send us an email. So, just so you know, we're going to start recording in 5, 4, 3, 2, 1. So, thank you very much for joining. This is going to be great. This is Applied Autodesk Product Design and Manufacturing Collection webinar. We're going to be talking about this great collection suite that we have. So we said it's going to be about Inventor and electrical, but there's going to be a little bit more than this, and I hope you're going to enjoy it. So I want to bring you to this little time travel. I don't know if you remember. I sure do. I first started college, and we had to do all the drawings by hand. So I'm not that old, but I'm not that young either. So, rulers and everything, that was awesome. But when I first got into AutoCAD 14 back then, it was just like an eye opener. It was marvelous. So this is where we are coming from. This great, they're doing everything by hand to this great innovation that was AutoCAD to what we have today. Also, not only do we have brand new technology, but we also have new challenges. It's so easy for anyone to be competing against us, and it's so easy for a startup to be financed by people. If you look at Kickstarters, so we have to be aware of this. How can we, spend more time innovating? How can we improve performance? How can we make our factory, produce parts quicker and better parts? So all of these questions are not very new, but we kind of got caught by surprise for most of us. So with product manufacturing collection, what we're giving you is very interesting. It's a common tool set. We have to work with the same data set. That's very important. Not only do we have to have one source of truth, but we also have, we need one file to be working on. No more personal version or, backup copies on a desktop. We have to share. We have to collaborate. It's funny. It's 2018. We have cell phones. We have text messages, Facebook messages. Call it what you want. We have all those different means to communicate, and yet we don't do it. How many of us, and I'm including myself in there. Of course, I have a 3D printer, so it's not as bad. But how many of us have produced parts, worked on parts, but it was not the latest and greatest version. It was on someone else's desktop. This is not, not good enough for today's day and age. With the collection, we have all these great software, Inventor that everybody knows, but also we included recently Nastran and CAD, and also HSM. Two new great addition, and this is what we're going to do with collection. We want to make this live. We want to make sure that it is growing. It is not the same old. Every time we have a new technology that I think it fits, we're going to evolve and make it available. So you see a lot of logos in there. We're going to talk about most of those. So, no, I love that title. Anyone can find something to work on or with. Engineers will use Inventor and also the almighty AutoCAD. Analysts, sim guys, sim people will use Nastran. The machinists will use HSM, and the factory planner might use Factory. But it's not to say that there's not something for everyone, and everyone can use pretty much everything. I love this picture. Never ever will we buy a car like this. So think about, it would be kind of crazy, for lack of better words, but it would be kind of weird to have to buy a car, with the wheels, and then we buy the car seats and whatnot. This is what the collection gives you. The sum is greater than just the price of one part. So if we go back to the tools that someone can use, the engineer will be using Inventor, will collaborate with the same files with the analyst, and this sim person, will maybe change the model, but also will be able to connect and converse and collaborate with the engineer. So it's not a one-way street. You can send the models to someone, and they will be able to work on it. Same thing with the engineer. Engineers change the stuff for the sim person, and they can go back and do the modification. Engineer can maybe start to do the tool path for the machinist. Machinist will work on it, maybe have some input to it, change some stuff, and then you know what? It's going to come back to the machinist. So we have to admit this is our best inventor, but it's going to be your best work. It will be easy to design and engineer, not only with the traditional, features and whatnot. It's going to be easy to do some advanced simulation and CAM and also factory design. But we're going to go into this. It's the same file. So whether you're using Inventor, we can also use point cloud. Reality capture is the fancy word for something that we all call point cloud. Large scale design review. I can't wait to show you this. This is very good. 2D to 3D, any CAD technology for the geeks among us, and also electrical or ECAD. So you get the latest and the greatest version of our tools. This is what the collection brings you. It's always going to be live. It's easy to update. It's easy to work with what you want to work with. A lot easier to install. I don't know if you've been through this, but guilty as charged. And also, it's just to make sure that everyone collaborates with the same tool set and also the same data set. So we have a company, a mental service, that the problem is they were outsourcing a lot of their stuff. It was expensive, hard to communicate, hard to get the latest and greatest, but also just, it was, how can I put this? It would take so much time to get results when they could be doing it in-house. So they discovered Nestor and CAD, and, they started collaborate using Vault as well. And guess what? I mean, it's now easier to do it in-house, to collaborate, than to outsource it, which is, it's just a little takeaway from this. Same thing with the freeze performance. Instead of, engineers sending it to machinists designing, cutting the part, they now collaborate on design. So they can actually build something together as one instead of just, my department, I'm going to take this file, I'm going to throw it over the wall, and someone on the other side of the wall is going to take it and manufacture it and maybe throw it on my side of the wall. No. We all collaborate with the same file. Now let's get into this. Before I start, I should have introduced myself earlier. So my name is Mark. I'm from Montreal. I'm a technical specialist for Autodesk. Yes, Montreal, so I speak a little bit funny, but I'm your geek in charge. So geek in charge allows me to not know every answer, but I know a lot of people that do. So if I don't know the answer, I'm not going to be afraid to say I don't know. I'm just going to get in touch and tell you or get the answer for you and send you the right thing. So please allow me to explain what the product design manufacturing collection can do for you. So we're going to start simply inside of Inventor. We have this great data set. It's from a customer named Aska. And what they wanted to do is they want to have a little bit more cycles. So you can see on the top right, you have this robot that's taking parts, putting them on those welding jigs, and they want to make sure that they could produce a little bit more. And by doing so, they need to have a little bit more lightweight fixtures, maybe change some actuators. So they need to look into what they could be doing to make sure that they get more cycles. And guess what? We're going to start working with this subassembly. So the goal is to change that big yellow plate. We're going to use Vault, but not necessarily Vault for a PDM boring, yawning system. We're going to use Vault as a design tool. And I'm going to explain it to you. So first of all, we're going to open design review to get the markups. It's very important. Everything is in there. So design review is awesome. Again, for lack of better words, but please excuse me, I'm French first. So we're going to get design review. We're going to know exactly what we need to do, and we're going to use the search tool from Vault using keywords, in this instance, 200 dash. And we're simply going to find everything that includes 200 dash. It's simple. And next thing you know, we use copy design because we might not want to modify that design. What we want to do is simply copy this design, create a new one so we can, have a branch of that design that existed. Copy design will allow me to give me the parent-child relationship, and I can be assured that everything that I need copied, everything I need modified will be there. And as simple as this, I get a brand new assembly, which is perfect. Now let's open this and let's work on that thing a little bit. So I have my new copy design. This is the new part. I will simply use some direct editing tool to move that face like this, and pretty easy. I mean, even I can do it. So next thing we want to do is we want to use a little tool called shape generator. And we want to make sure that we use the load and we use the pressure, the force, whatever you need to maybe create a shape that's going to be optimized. Now, the result might be a little bit space age, but it's going to be pretty interesting. So now what we're doing, we're saving those regions. It's important to not touch those regions. And guess what? This is what we have. This is the best optimized part that we get for our load, our stress, our fixtures. Everything is in there. We could use that STL file, or simply the best way to do it is use the sketching features and all of that to just mimic what the result looks like, to have something that's a little bit more pretty. So we get this part, everything is in there. I can add fillets, I can modify the part, but at least what I have is the basis. It's the backbone of what the shape generator gave me. So look at this. This is very impressive, and this is the optimized with the material and stress and factors. Everything is in there. So what we're going to do, we're simply going to search from Inventor. This is what I was telling you, that we have as a design tool. So from Inventor, I'm looking for files, I'm searching for files to simply replace what I want. Look, now this yellow bracket now that I was telling you was also done with Shape Generator. So it gave me something that's a little bit easier to and lightweight also to work with. So, first goal is pretty much met. Now what we're going to do, we're simply going to check in this assembly inside of Vault from within Inventor again. Never left Inventor. If I don't have to, I don't have to. I'm simply going to, search Vault or do my shape generator inside of Inventor as well. Now let's check in this, and next thing you know, we're going to simulate this. So I love using simulation because it's within Inventor. It's not a new package. It's not anything new I need to learn. Everything is in there. And you don't have to be a PhD in FEA, nice acronyms right there, to be using Navisworks and CAD. Anybody can use it. You want to know if you're in the right direction. You want to know if you're not over-designed or whatnot. I mean, safety factor and displacement, anybody can do this. Of course, you're going to have to pass the information to a colleague for that colleague to actually seal that design. But it's the same source. It's the same file. You just use something that was available to you that you know exactly if you're in the right direction. You actually make it simple for your colleagues to work with you. So Navisworks and CAD, pretty simple. Material, fix some places, you add some load, and you get the results. Look at this. Anybody can get that. I mean, even, again, I can do this. So interesting. Everything is right in your face. And it's graphical and it's within an interface that we all know. Now, what's not to love? No, look at this. Maximum displacement versus load scale factor, everything is in it. Of course, there's a lot of advanced features in there, but please don't be shy to use it. You can use it at least to select the right material. Do we use plastic or do we use aluminum? So it should be in everybody's hands. So back into my weld cells. Let's take this part and maybe, just maybe, let's do some toolpaths for that little part over there. So everything is integrated. HSM is there. We can cut. We can, again, use it to give us a sense that, if we're in the right direction or not. And we can mount this. We can do everything that's available for a machinist. So it's always trying to get to the next level as simple as possible. We're not machinists, or I'm not an FEA, PhD degree, whatever. but I'm using the tools to give me a sense of confidence that I'm actually doing the right thing. So right now we can get reports and everything just to make sure that it's going to be simple for our colleagues to work or even show that we're doing progress. Look at this. Always inside of Inventor, very easy to use. Now, we're going to turn it up a little bit. We have a bracket that's from the BAC model. So we're going to go in Vault again, using Vault it the same way. Now, I don't know if you noticed, but this is a PDF system, a PDF file. So we got a report from FEA. Oh, there's some, I thought about this. So there's a report, a PDF that tells us that we need to change the bracket because maybe it's over designed. Maybe we need to, have something that's a little bit more lighter. So we're into Vault searching for our files. We're going to simply open it. We can also go into design review. We can look at it. If there were some notes in there, we could have changed it or modified them. We're going to go into copy design again. Copy design is simple. It's like copy paste, but with all the links and all the files, and you decide which file you want to copy or simply keep. So for some library parts, maybe. All right, so we're back in Inventor. We're gonna again find something. We need a DWG drawings. There's a lot of AutoCAD drawings out there, and it's good. There's so many 2D geniuses, aka geeks out there. We have to leverage that. So about AnyCAD, how we can read pretty much anything inside of Inventor, whether it's a PGC file or other CAD system file. Well, we can do the same thing with our file. It's called DWG underlay. So we have this nice AutoCAD drawings. We're going to simply pick the layer that we need to use. And in that case, I'm going to remove all the information when I don't need. So there you go. We have the top, front, and right view. And we're going to go from there, and we're going to simply use those sketches to convert them and maybe simply do some extrusion. I'm going to add dimensions over there because I need to dimension and see what is going on. So it is very simple for me to start from a 2D drawing and create a 3D part. That's going to be linked. You know what? I just blew the punch. It's actually going to be linked to your AutoCAD drawing. So isn't that nice? So we go from there. We can have the 3D part. Everything is created from that DWG. And we can also have and modify the information needed. So adding more information like this, creating more 3D patterns and whatnot. And there you go. We have this great 3D part. Now we're going to use the content center as well. I mean, why do we have to remodel everything if it's available in library for us? So we're simply going to go use a bearing and drag and drop it in there. So guess what? Next thing you know, we're going to check it in the vault. As simple as this. Adding a little comment. It's important to write comments because if you don't write comments, then people won't know what happened to your file. All right, so next thing, we are creating a drawing. We need to have a drawing that's going to be associated to this part. And what's awesome about it is it's also linked to your DWG file. So look at this. We have now the part that's going to be, we're going to replace it. And next thing you know, we're going to do a little sim on it. All right, perfect. So we're just making sure that the load is there. We know exactly what has been fixed. We're going to put all the information needed. And as I was telling you, you don't need to be a certified FEA expert. What you need to do is making sure that you have the right information because, as you all know, in FEA, garbage in, garbage out. So what we want to do is we want to know if we are in the right direction. As you can see right now, we have the mesh, and it's very quick. I don't know if you noticed how quick it was, but we get the information right there. And if it's not meshing quick enough for you, you need to look at it a little bit more. Of course, that's a joke. So we get all the results. We get, we know exactly how the part will react. And as you notice, there's a little bit of buckling in there. So maybe we need to see how the warranty is going to be affected to this. So what we want to do is we want to make sure that we have a cycle that's going to tell us how much or how long we can run this before it breaks. Because as you figured out, and as you saw, this is a component from a car, and it's a performance car. So I don't want to be driving like a madman around a track. Next thing you know, well, someone at the company didn't do a cycle, a fatigue cycle. So there you go. We have all the results needed. We can, see the solid life of it, exactly where it's been um, uh, solicited. All right, so back into my AutoCAD drawing. Again, Vault is available throughout the collection. So whether you're working from Inventor or AutoCAD, it's available to you. So we have the drawing. I could change something in there. And like I was telling you, there's a lot of 2D drawings out there. We should, beneficiate from that. It's not everyone that's a 3D prone. A lot of people prefer to work in 2D. We change the drawings. It changed the 3D model as well, as quickly as that. We don't have to do anything, or no magic at all. No hocus pocus, and everything is in there. There you go. Changes. I can still add my modification in there. If I go back to my sim, I just have to remesh, relook at the result, and everything is taken care of. And this is all linked. As I was telling you, we have to have one single source of truth, and we have to work on the same files. There's no need to have a parallel world where you have a file and someone else has a desktop version of it and everything like this. So there you go. This is the car. Guess what? We're going to check it in inside a vault, and please write a comment. It's easier to follow what's happened. The history of the file with a comment is so much easier for anybody that's going to be collaborating with you. Pretty simple so far, and everything you saw is available in the collection. So you are 2D master or 2D master, you have something for you. So again, we could use a part, we can set up a toolpath needed, and everything is from Inventor as well. Those are advanced features, but it's always to give us some sense of direction. And it's great to be able to collaborate with machinists. They tell you what's good, what's not. We create reports. We can keep track of what happened. And pretty simple the way it is. They can send us, or they can do therapeutic editing modification as well, and they can simply change the toolpath, and it's gonna be easy like this. Now, again, we started at the level 1, we all the way up to level 5 want to go, and now this is very interesting. So we started with something called Navisworks. Navisworks is like a lunchbox for CAD files. If you look at it right now, we have a factory. Now, what I'm doing is I'm doing a walkthrough. And in Navisworks, you pretty much can manage all your projects all in all. So you can have files from any CAD system. And I'm going to surprise you with something else, but I don't want to burn my punch. So we can see that this company is building ATVs. So Vimic is doing nice little ATVs. And we can see the plant. Everything is in there. Everything works perfectly and smoothly. But what if Vimic got a big contract? Or what if they decided to bring in a new model? They need to make sure that they have enough space to do that. Maybe they're going to add a new line, a new weld cells, or something like this. But we're going to show you how we can take this great 3D models. As you can see right now, I don't know what they're doing with this empty space. Maybe they're playing dodgeball or something. But we see a place that would be perfect for the new line, for the new model. So what we're going to do is we're going to try to use that and integrate a new line, maybe because they got a new order, or maybe because they just want to add a new model as well. So I'm going to start with process analysis. Now, this is great. A lot of people want to know, how can I map what I want to do before I do anything? Some people will use an Excel spreadsheet like this. It is great if you are the person that did it. Not so great for the person that needs to read it. So what if we could map this into something that's easy to understand like that? So we're going to go into our asset browser. We're going to look for what we're trying to achieve. So right now, I want to build some chassis. Chassis will be my end result. Maybe I'm going to add more lines into this. Maybe I'm going to add more cells into this. And what's great is everything I'm doing in this little mock-up I will be able to reuse in AutoCAD and Inventor. So I'm adding some processes in there, and I'm tweaking what I need. So let's say I want this to be built. The work cells, the Vimic work cells are going to be there. I can change also the settings, and this is going to be great. So I'm just adding some step processes. And once I go in there, you will see on the right side, I will change values. So the action type is going to be merge, and we also have maintenance cycles. So everything that is good and on paper, I can actually do a little analysis of the processes. So right now I'm just running my process. As you can see, I have green is good, but we have some yellow signs telling us maybe it's as good as we thought. So what I'm gonna do is I'm simply gonna double that. I'm doubling down, and this is pretty quick. I don't know if you noticed. I just drag and drop, change some information or setups, and now I can know just by clicking play pretty much where I'm going. As soon as I'm satisfied with what I have, I'm going to turn this into a 2D model. But wait, there's more. So right now, I changed some value, green everywhere, looks pretty awesome, perfect. So that should be good enough. We're simply going to look at the report. You see where we're going, what's going to be the efficiency, and how we're going to use connections and whatnot. So, all right, so maybe this is where I want to go. Now, report is good because I can always put that in default. I can always have a tracker history of what happened. And what I want to do right now is I want to save this because I'm going to reuse this. I just went drag and drops a few of my assets, changed the values in there. I'm going to save this so I can reuse this. Again, there's no way that we can be efficient if we have to have different files. It's going to be the same file that I'm going to open in AutoCAD. And what we're seeing right now, we started with Navisworks, but what we're seeing right now is factory. So it used to be called factory design. It's pretty much the same thing, but wait, there's more. So this is my test cells. This is what I've been using. This is very good. Everything is in there. All the information I have is in there. So what I need to do is simply place it. Good old AutoCAD tricks, flip and rotate and whatnot. We create assets, we move it there. And what I love about this is that it's easy to use. It's simple to use. You might be a 3D, then my God, it's still going to be pretty simple because it's pretty much drag and drop and move around. We can create and have more assets added as well. So like I was saying, you go into your asset browser and you want to start building a conveyor. And what I love about this is that those 2D blocks are connected. So it's easy to drag and drop and just to the connection point. Everything is linked together. So you save the change, everything will be seen there. You can also change details from your assets. So we have an analysis that was telling you if the production would be good. But let's say you decided a process would not be the conveyor belt, but it will be actually people moving around with the components. You can see how much energy and how much money you will spend. Everything is linked, and this is through the factory add-in. So you can use the process analysis, or you can use the tools within AutoCAD as well to tell you if you're in the right direction or not. It's always about knowing what will happen. So the schematic tool from process analysis is great, but having something that's a little bit more, I don't know, engineering-like is also very good. So this is why we have the tools inside of AutoCAD with the factory add-in. So now we're going to sync it with Inventor. Everything we did, you see the little layout that just appeared? Everything we did in AutoCAD will be available to us inside of Inventor, and it's building those 3D models. So those 2D blocks actually come from a 3D model. So you have an asset, you can add it to your library. And see, we're simply drag and dropping some little jibs, which is simple. We can know where the radius of action is. We can change, we can add it, we can modify the conveyor. So we start with a 2D layout, but it's also giving us this depth or this 3D aspect of it. And it all comes from the process analysis we did. Of course, if you don't want to go through the process analysis stuff, you can start in AutoCAD, plain old AutoCAD, and start drag and dropping your assets, and it's going to sync with a Inventor file as well. Now, back into my Navisworks, because guess what? Yes, you can sync from AutoCAD to Inventor. We saw that. But you can also sync from Inventor to Navisworks. So in the beginning, I was telling you Navisworks is like a big old lunchbox of CAD files. This is where you should be able to present or look at your models or your factory. So we start from the same place. This is the line that we're building our ATVs. Everything is in there, but let's see what happens to my dodgeball alley. So I don't know if you saw, if you were quick enough to see, but this is what we have. This is our factory. But look on top of it, you have this little point cloudish thing. It's actually a scan that we got from a factory. So you look at at those point clouds. The reason we're going to use this is that it's not all factories are done according to plan. Some factories will have modifications inside of them, but we can actually use a point cloud and do a clash detection to see if our new layout is, having interferences with what's in the building. So instead of trying to remodel everything and measuring it, it's very complicated. Get a scanner, get a point cloud, put inside the Navisworks, and do your study there. So we can change our 3D models information. Of course, everything we do in 3D will be sent or synced with AutoCAD, and everything we do in 3D will also be available inside of Navisworks. The clash detection we can see there. We can also modify, and Navisworks is great because it's one single source of truth. If you have also a project files, those Gantt charts, you can, add those Gantt charts inside of Navisworks as well and follow what's being built or what's being modified. So again, having a drawing is very important. So we're going to take this information, we're going to create a simple view drawing, and we're going to add the bill of materials, of course, because we can keep all of this inside of all. So process analysis to AutoCAD, AutoCAD to Inventor modification, 3D. It may be easier to understand. Maybe not everyone prefers 3D. And then from Inventor 3D inside of Navisworks. And from there, we create a drawing to have some type of modification or documentation, I should say. We add some balloons. It's very simple to use. So again, this is from the collection. So you get everything in there. I see there's some questions in the panel. I'm going to answer them as soon as I'm done with the presentation. There's a Q&A portion at the end of it, so it'd be my pleasure to answer them. I'm going to finish this great presentation. We're going to try to wrap it up with something else. So I'm adding more and more features, but the fun part, it's easy for me. Everything is available to you. And right now, I don't think I've showed you anything that's out of this world. Anybody can pretty much use what I showed. You know what? You can use it. So what we're going to do now, we're going to go and try to connect everything we did in the factory. And we're going to use some AutoCAD electrical information. So we have our factory. We have these new cells. We also did some new welding cells. But we're going to connect those generators inside this robot. So we need components and we need some wiring or cables. Always hard to make a differentiate them. So it's simple, and most of the times customers will take an electrician or anybody that's involved in connecting those robots, and they will say, "Well, go buy some cables." It's easy if you're doing this once a year, but if your business revolves around connecting robots, buying cables or wires just a one-off is not suitable. It's not going to be a great way to make a business. So what you want to do is you want to be precise. You want to know exactly what's going on. So we're going to add connectors from both ends. And what we're going to do is look at this. This is all a 3D model. It's very interesting. And what we're going to do is simply going to go inside of AutoCAD. We're going to reuse the same connectors because everything syncs. And what we're going to do, we're simply going to create this great rainbow of colors that's actually connecting all the information needed. So from one pin to the other, it's as simple. Of course, maybe with this, I was telling you like FEA, you should use it, even though you're not an FEA expert. Same thing with HSM, which is a toolpath for CNC machining. With AutoCAD Electrical, you need to have a little bit more information. You cannot guesstimate this. But look, if you have the right information, look how simple it is. I'm clicking one pin to the other. I'm adding one wire and whatnot. Everything is in there. You don't have. It's not. It's as simple as this. And I urge you. I encourage you to try it. It's very simple to use. And sit down with one of your colleagues that maybe you don't collaborate too much, and let's try to use this and look at their face when they're going to get see the results. So we have all the links linked. That's funny to say. Everything is in there. You see the pins, and we're simply going to assign it to a componentry. So by doing so, we're going to create those cables that we need to see a physical aspect of it, because it's easy in 2D and it's easy to measure, but sometimes we want to know if there's any clashes, if there's any interferences in there. So having a 3D model of it is it's the way to go. So you see all the wires that we have in there. What we're going to do is we're going to create a route that we're going to bring this inside of our component. So it's not like those lines that just floating in the air. So I'm adding all this, and you can see the cable is growing. The harness, I should say, is getting bigger. And then we can put inside a rail, connect it to the robot, and it's pretty much that simple. Now, of course, we need a drawing of this. This is going to be important for the person cutting the wires. So the drawing is very well done. It's simple, again, to read and use. So in the drawing aspect of it, we're not going to need everything. We're going to go focus exactly on what's necessary. So harnesses are there, cables or wires, call it what you want. Again, it's not a personal choice. I know there's a scientific value for harness cables and wires, but look at this. You see the connectors in there. You can also get the numbers connecting what to what. We can do a little. We can change our views. We can change the connectors, and this is all Inventor. So if you ever done any drawing inside of Inventor, you can use the same tool. So it's all integrated into one platform. Now, doing the connections, it's simple. We're gonna make all the numbers available like this as quickly as it was. It's a single source of a single file that people are working with. It's the same file, and we communicate with this. Now, let me stop there. That was, in a nutshell, a Mac 3 55,000-foot overview. But I just want you to have the feeling that if you have the collection, if you subscribe to the collection, you will get a lot of tools. I don't want you, if you don't have it, and if you're thinking about subscribing to it, don't look at what you're doing today. Think a little bit about next week, the next project, the next initiative, the next contract you're going to get. Maybe having a collaboration between FEA, the machinists, and also the ECAD people will be of value. There's a lot of value in communicating with the same software and also using the same models. If you have questions, please submit them in the chat window. If you're thinking about something, if you debrief about the 110,000 words I just said in about 45 minutes, don't be shy. Don't be afraid. Send us an email. It'll be my pleasure to talk with you and explain it to you. And if you want to see more, again, please get involved with us. That will be our pleasure. So if there's any question, please ask them. I just want to make sure that everybody's unmuted. Can I do this? Also, this webinar has been recorded. So if If you want to if you want to watch it again, if you want to share with your colleagues, please do so. Some questions I once had. Navis Navisworks is uh, a great way for you to do larger scale projects. Also, it's a great viewer. If you have models that you're not too sure, you want to maybe open an inventor or you don't see where you're going with this, Navisworks, just throw it in there and it's going to be pretty simple. If you're involved with BIM technology or standard, if you're working on large like factories, Navisworks is also good. Make sure you have the same 00 and you can just drag and drop stuff in there and it's pretty simple. The Another question, the AnyCAD um, call or technology is great because we can read pretty much anything that's out there. What AnyCAD will give you is pretty much like I did with a 2D drawing, is that if you get another CAD system file, you don't have to convert it. You just open it inside of your assembly, and if that other CAD system file changes, it will upload inside your Inventor assembly as well. Same thing, we have this AnyCAD technology that works between Fusion 360 and Inventor. I didn't talk about Fusion 360, but if you have any questions about it, please don't be afraid to reach out. So that's pretty much it. I'm going to give you, oh, wait a minute. I have a question here. Just give me a second. Okay, no, I'm sorry. So thank you very much for your time. This will be recorded and available to you. And if there's anything, please get in touch with us. Thank you very much.